Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started.
Well, we are about to witness one of the most anticipated and unusual Starship missions yet. Flight 12, the first ever launch of the V3 Starship. This marks a critical turning point in SpaceX's long-term vision for deep space exploration and rapid reusability. With major upgrades across the rocket, pad, and engine systems, Flight 12 will not only test the next-generation hardware, but also determine whether SpaceX's bold roadmap toward Mars and beyond stays on track. This isn't just another step, it's the most ambitious test in Starship's history so far. Flight 12 will debut the first V3 version of Starship, representing a complete rework of both stages, from propulsion to structure to flight systems. The mission profile itself will look familiar. The fully stacked Starship will lift off from Starbase, climb through the atmosphere, separate into two stages, and continue its flight into orbit. The Super Heavy booster will then attempt a controlled descent for an ocean splashdown, while the Starship upper stage will deploy a test payload, perform in-space maneuvers, and then re-enter Earth's atmosphere for a controlled landing attempt. SpaceX will not attempt a tower catch this time. The focus is on validating the new systems under real flight conditions before moving on to more complex recovery operations. What truly sets Flight 12 apart, however, are the extensive hardware upgrades across nearly every part of the system: the rocket, the pad, and the engines, marking a new generation of Starship development. For the first time ever, SpaceX will launch Starship from the new Pad 2 at Starbase. This launch complex is a complete redesign from the previous setup at Pad 1. Instead of the six-legged orbital launch mount with its inverted water-deluge steel plate, Pad 2 features a box-shaped orbital launch mount, OLM, equipped with dual flame trenches beneath it. This new configuration is designed to better manage the tremendous forces produced by Starship's Raptor 3 engines, diverting the exhaust in two opposing directions and reducing the thermal and acoustic stress on the launch infrastructure. SpaceX learned valuable lessons from earlier flights, where the pad sustained damage under the extreme thrust of the Raptor engines. The new dual trench system and upgraded deluge capability should provide greater durability, allowing for faster turnarounds between launches. The chopstick arms on Pad 2 have also been redesigned. They are shorter, stronger, and better reinforced to accommodate the larger and heavier V3 Starship. During Flight 12, these arms will mainly assist with stacking the rocket, but future missions are expected to reintroduce the catch attempts that Elon Musk envisions, where the arms grab the returning booster mid-air. Below ground, SpaceX has made extensive changes to the tank farm and fuel lines. It's unclear whether Pad 2 will use a separate dedicated propellant system or share resources with Pad 1. But recent construction activity, including the installation of larger pumps and new fuel transfer lines, suggests SpaceX is preparing to support higher propellant flow rates.
This is essential because Raptor 3 engines consume fuel more aggressively due to their increased thrust and efficiency requirements. And that brings us to the star of the show, the Raptor 3 engine. For the first time, both stages of Starship, the booster and the ship, will fly with Raptor 3s. 33 of these engines will ignite at liftoff, producing a staggering 9,000 tons of thrust, making this launch one of the most powerful in human history. To put that into perspective, that's nearly 3 times the thrust of NASA's Saturn V. But raw power isn't the only improvement. Raptor 3 has been redesigned from the ground up, with fewer parts, simplified plumbing, and more robust ignition systems. These improvements are aimed at enhancing both performance and reliability while reducing manufacturing complexity and cost. SpaceX's long-term goal is to mass-produce these engines for rapid reusability, so achieving consistent, reliable performance during Flight 12 is absolutely vital. Any issues here could slow the entire program. Another key upgrade lies in the hot staging system, the process that allows the upper stage engines to ignite while still attached to the booster. Previously, Starship used a separate hot staging ring between the two stages, which added mass and complexity.
Now, the hot staging structure is integrated directly into the top of the booster, making the system lighter, simpler, and more robust. The integrated ring allows smoother stage separation, reducing debris and improving efficiency. By eliminating an external ring, SpaceX also saves valuable time during stacking operations, making the entire assembly process more efficient. This design change aligns with SpaceX's long-term goal of rapid, almost aircraft-like launch cadence. The grid fins on the booster have been completely redesigned as well. Their new geometry, larger, lighter, and more heat-resistant, allows for improved aerodynamic control during descent. These new fins also include built-in catching interfaces, meaning they're already designed to connect directly with the chopstick arms in future recovery missions. While Flight 12 won't involve an actual catch attempt, this test will be a crucial opportunity to gather data on how the new fins perform during high-speed re-entry. Stable guidance and control are key for SpaceX's ultimate goal, fully reusing the booster by catching it mid-air with precision.
I'd like to quickly remind you to subscribe to our channel if you haven't already. We regularly upload informative SpaceX and space news videos that you won't want to miss. Be sure to turn on the notification bell so you're notified whenever we release new content.
The upper stage, the Starship itself, also features a long list of changes. One of the most significant is the heat shield, which has been overhauled after the lessons learned from previous flights. The V3 Starship's tiles use stronger materials, improved attachment methods, and a more uniform pattern to better distribute heat loads during atmospheric re-entry. The aft flap area, one of the most vulnerable sections during descent, has been heavily reinforced. The new design not only enhances survivability, but also improves aerodynamic stability during the flip and landing maneuvers. SpaceX is pushing for a heat shield that can withstand multiple re-entries without major repairs, which is essential for achieving full reusability. Inside the ship, SpaceX has also updated its payload deployment system. While past flights primarily carried test weights, or dummy payloads, Flight 12 is expected to carry and deploy an actual payload, potentially a small satellite or technology demonstrator. This will test Starship's ability to perform real orbital operations, a crucial step toward commercial missions. The ship will also conduct an in-space engine relight, verifying that the Raptor 3 can restart reliably in the vacuum of space. This capability is vital for future missions involving orbital refueling, deep space transfers, and lunar or Mars landings. Meanwhile, on the ground, SpaceX continues to race the clock. For the mission to launch within its current timeline, which has recently shifted to early 2026, according to latest update on X, the company must complete several key milestones in rapid succession. As of this week, Booster 18 and Ship 39 are the designated hardware for Flight 12. The booster is nearing final assembly, while the ship is entering its stacking phase inside the high bay at Starbase. The new Pad 2 infrastructure is still undergoing integration, with major components such as the dual-flame trenches and water systems in the final testing stages. Before launch, both stages must undergo independent cryogenic proof tests, full-pressure tank trials, and multiple static fires, all before a combined wet dress rehearsal. Only then can SpaceX proceed with the full-stack flight test. Even by SpaceX standards, this is an aggressive schedule. The company is known for pushing hardware to the limits of testing speed. But each of these new systems, from engines to pad structures, must be validated before liftoff. Any delays in cryogenic testing or static fire results could easily push the launch further into 2026. Nevertheless, the company has demonstrated before that it can accelerate when needed, so a January 2026 target remains feasible if no major issues arise. When the day finally comes, Flight 12 will test not only Starship's engineering, but also the scalability of SpaceX's vision. This mission must balance innovation with reliability, experimentation with performance. The upgraded engines, pad systems, heat shield, and aerodynamic components must all perform near flawlessly for the program to move forward toward orbital refueling and full reusability. SpaceX's ability to rapidly iterate, test, and learn has always been its greatest advantage. But as Starship matures into a true launch system, the margin for error shrinks. If Flight 12 succeeds, it could be one of the most defining moments in modern spaceflight, the transition point where Starship evolves from an experimental prototype to an operationally capable system. A flawless flight would validate the Raptor 3 engines, the integrated hot staging, the dual-flame trench pad, and the reinforced heat shield, all of which are essential for high-frequency, low-cost launches to orbit and beyond. On the other hand, if major issues arise, especially with the engines or the heat shield, SpaceX may have to rework the design yet again, potentially delaying the entire program. But as we've seen time and again, SpaceX thrives on iteration. Every failure has led to a leap forward, and Flight 12 is the culmination of all those lessons, a bold, calculated step toward full reusability. Elon Musk and his team have been uncharacteristically quiet about this particular mission, perhaps signaling the scale of changes being tested. From the outside, this silence only adds to the anticipation. With the new V3 hardware, upgraded pad, and improved engines, Flight 12 is shaping up to be one of the most complex and high-stakes Starship missions ever conducted. It's not just another test, it's a rehearsal for the future of human space exploration. If everything works as intended, this flight will bring SpaceX closer than ever to achieving rapid, fully reusable launch operations, the key to affordable lunar, Martian, and deep space missions. The countdown to Starship Flight 12 has officially begun, and with every tank test and static fire at Starbase, we move one step closer to witnessing what could be a defining leap for humanity's journey beyond Earth.
Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.